Assalamualaikum and hello everyone. Today we will go to the new chapter where I will talk about the introduction and definition of the Laplace transform. So in Laplace transform, I will prefer to use the term t instead of using x term, but it is actually the same thing. Okay, in previous chapter, we have dealt with solving first and second order differential equation given example by this function. Okay, so for the ft here, we have two cases where we have homogeneous and non-homogeneous case. So for homogeneous, we have covered for the ft equal to 0. Okay, whereby for the non-homogeneous cases, we have ft not equal to 0. It can be constant, it can be exponential, sine, trigonometry, ln, and 1 over t, and so on. Okay, so what if ft here is a piecewise function? So what does it mean by piecewise function? So let's say I give example here. This is t and this is ft. Okay, so let's say from 0 to any constant, we have a function here. Okay, which is ft. Okay, and then from here we have another function which is f2t. So we consider this as a piecewise function. Okay, so previous method cannot solve this type of function, but this kind of ft always occur in the engineering problem. So therefore, we need to use other method which is Laplace transform. The basic idea of Laplace transform is it uses a transformation from the t domain to the s domain by using the operation known as Laplace transform of ft. Okay, in the s domain, we can rearrange the equation using some rules. Then we transform back into the t domain by using inverse Laplace transform of fs. Okay, so when we find the Laplace transform, we use small t. When we want to find the inverse Laplace transform, we use capital F. Okay, so what is the definition of the Laplace transform? So let f be a function over 0 to infinity. Then Laplace transform of ft is given by the integration from 0 to infinity of the function e to the minus st multiplied with that particular function dt. Okay, let's go to the example here. Find the Laplace transform of ft equal to 2 using the definition. So from this is the definition here. So we just have to substitute into the formula. So first we need to define what is ft. So in this example, we have ft equal to 2. So to find the Laplace transform of ft, which is equal to 2, so we just substitute into the integration here. We have 0 to infinity e minus st times ft equal to 2 dt. Okay, so 2, since 2 is a constant, we can bring this one out from the integration. So we have 0 to infinity only involve e minus st dt. Okay, so remember we integrate in terms of t, so this is t term, so we cannot bring out. So to integrate this one, so we consider the t here, we will have e minus st. To integrate of exponent, we just put the constant here, okay, towards downside here, so we will have negative s. Then we substitute the limit here from 0 to infinity. Okay, so the limit here we will substitute into value of t. Okay, we need to substitute into t. So negative s, I can bring this one out. So we just write down 2 minus s. So we will have e minus st from 0 to infinity. So when we substitute here, okay, we want to substitute t with the infinity. Okay, so this is definite. It is actually equal to, Okay, when we want to substitute from 0 to infinity, it means that we want to substitute limit of t that goes to infinity. Okay, the t approaching infinity. So we just substitute from 0 to t, which means we try to substitute with some definite value. Okay, so just write down 2 over minus s. So we will have e minus s t, we substitute with the infinity, minus exponent negative s t, we substitute with the 0. Okay, lower limit. Alright, so when we talk about here, we have e minus s multiplied by infinity. So negative s multiplied by infinity, we will get, okay, negative value multiplied with a big number, so we get another negative infinity. Okay, if we have positive value, then multiplied by infinity, we will get positive infinity. So maybe we can simplify for this case. We will have negative 2 over s e minus infinity minus exponent negative s multiplied by 0, we get 0 here. Okay, then we want to simplify e negative infinity. Okay, if you refer to the calculator for the big number of infinity, we will figure that it is approaching towards the value of 0, e minus infinity. But if you try to find e infinity, it is actually not defined. Okay, not defined. So to convert from e negative infinity to 0, must make sure that there is always negative here, so that it will become 0. Okay, so in this case, we have negative 2 over s e minus infinity. Okay, when we use the limit here, it is actually 0. Minus exponent 0 equal to 1. Then we will have negative 2 over s, negative 1. Simplify, we will get 2 over s. So we can make conclusion that Laplace transform of 2 is actually equal to 2 over s, where we convert from t domain into the s domain. Okay, let's do the same example. Find Laplace transform of ft equal to t using the definition. So in this case, we have ft equal to t. Right? So first, we substitute ft equal to t. We define this one first. Then to find the Laplace transform of t, we just substitute the value here. 0 to infinity integration, where we have e minus st. The ft here will be substituted by t. Okay, so we find from this equation, we have t multiplied by exponent minus st towards tt. Okay, so we need to solve the integration by using tabular method. So how to solve by using tabular method? So we can plot u and dv. So our u will become t and dv will become e minus st. So for t, we differentiate t, we get 1. We differentiate 1, we get 0. Exponential minus st, we integrate this one, we will get e minus st over s. Then we differentiate one more time, we get e minus st over minus s multiplied by minus s. Okay, which is equal to e minus st over s square. So up to second, okay, second to third, and I always put plus minus plus. Okay, so when we want to integrate, we will get the answer will be t multiplied by exponent over negative s, we will get negative t e minus st over s. Okay, this is minus plus, we get minus exponent minus st over minus s. s square. Okay, and then the last level is always plus integrate 0. Okay, from the limit here is 0 to infinity. So we have to substitute the value 0 and infinity towards t. So we get negative infinity exponent minus s multiplied by infinity, okay, over s minus exponent minus s infinity over s squared plus integrate 0, which is equal to c. So we don't have to put plus c, because c, if minus c, we'll get 0 back. Okay, so just ignore the c here. We will have negative. Substitute now t with 0. So t here is equal to 0. So when we multiply with any equation, we get 0. Okay, 0 minus exponent negative s multiplied by 0 over s squared. Okay, then we will have, here we have minus s multiplied by infinity, we will get negative infinity. So e minus infinity is equal to 0. So 0 multiplied with any value, we will get 0. Okay, so just put 0. So minus e minus infinity, okay, so we get also 0. So remember, e minus infinity is equal to 0. So here we also get 0. Then minus with 0 minus exponent 0 multiplied by negative s is 0. So exponent 0 is equal to 1. So 1 over s squared. So when we simplify all this, we will get negative, negative, we will get positive, right? 1 over s squared. So Laplace transform of t is equal to 1 over s squared.